All right, so here's page 2 of your review. Okay, so first couple questions here, we're just focusing on finding the domain like we did on the last page that we just looked over. Okay, so we're going to look at range first, again, which is the y-axis of your graph. And then we're going to look at, and then we're also going to look at domain, which is your x-axis of your graph. Okay, so starting with domain. Domain, again, is the left limit and the right limit. So basically, is there a limit going to the right, or does this graph keep going forever in one direction? Now notice there's arrows. So there's arrows on the left side of this graph, and there's arrows on the right. So if there's arrows, that means on the left side, there is no limit. It just keeps on going. So that it keeps on going towards negative infinity because it's continuing to get more and more negative. And to the right, it's getting more and more positive, so it's going to approach positive infinity. So I'm going to set this up very similar to what I did on the last page. I'm going to have x in the middle, except this time all I'm going to put is less than signs. I'm not going to put equal to, because you never really can get to infinity and actually get to like an actual value, so you don't put equal. So I put infinity on one side and then infinity on the other. Okay. Now for the range, I start with the lowest value, and notice the lowest value is down here at, what is that, 3? And then at the top of the graph, there is no limit. It just keeps on going. So that means the upper limit is infinity. Everything is basically, it's everything greater than 3. So I'm going to write this two different ways. The first way I'm going to write is the lower limit, 3, and the upper limit, which really is no limit, it's infinity. And I'm going to, again, write y in the middle. And since 3 is an actual value, I'm going to put equal to. But for infinity, I'm going to put less than without the equal to. Okay. The second way I can write this is, notice it says y is greater than 3. I can just pull that part out and write that part alone, because that pretty much sums up the range. Is it's just y is everything greater than or equal to 3. Okay. So either of these ways are acceptable. All right, so then for domain, again, I'm going to go ahead and write x in the middle here and less than. Okay, and also the same with y, and we'll figure out if we need the equal to or not. Okay, so for the left limit, now this graph doesn't have any arrows, but I can tell you right now that they do intend to show that that keeps on going, okay, because it goes off the graph. So because it goes off the graph and it keeps going, it's negative infinity to the left and positive infinity to the right. So positive infinity and negative infinity. And then it's also going to be the same thing for y, because it goes down forever. It never stops going down in the downward direction. That's negative infinity on the lowest value or lower limit. And then on the top, it keeps going up forever. So that's also going to be positive infinity going in the up direction. So for down here, I'm going to write y is greater than negative infinity, but it's also less than positive infinity. Okay. All right, now list all the points below. All right, so all I'm going to do is I'm going to convert this into coordinates. Okay, so that I know how many coordinates I have based on how many lines are connected. So I see 1, 2, 3, 4 lines. So that means I'm going to need 4 coordinates. Okay, so now remember, this is all your x values, and this is all your y values to the right. Now you see that this, starting with the first number on the left, -1 connects to 5, so that's the first coordinate, -1 and 5. Then the next arrow is 0 going to 3, so that's 0, 3. The next arrow would be 2 to 3, so 2, 3. And then from 3 to -1. Okay, now the question, is that a function? It is a function as long as each of these x values or inputs only goes to one value. And notice they all only go to one y value. So that is a yes. Okay, so now what we're going to do is basically take all these coordinates and graph them on the graph over here. So starting with -1, 5 over 1 up 5. Then 0, 3, that's right on the y-axis. 2, 3, so 2 over 2 up 3. And then 3 minus 1. And then you'll notice that this also passes the vertical line test. So that also confirms again that this yes is a function. Okay. All right, so now evaluate. Remember, evaluate, all we're doing is we're going to plug in this input that you're given into the x of the function. So I'm going to plug in 2 times minus 6 right there, and then simplify that. So 12 times negative 6 is negative 12, and then I add 18 and negative 6. So that's the output. You're given the input, you got to find the output. We're given the input on all of these, okay? So again, I'm going to plug in that x value not only to this x, but both of them, because I always plug into both x variables. So negative 4 squared, then plus negative 4. All right, so first things first, with this one, I've got two things going on. I've got 5 times 4, and I've got negative 4 squared. But PEMDAS, remember, I got to follow PEMDAS, and that, the order of operations tells me that exponents comes before multiplication. So what I want to do is do negative 4 squared, which is negative 4 times negative 4, which is 16. All right, now this is just plus my negative 4, so I can just rewrite this as just minus 4. Now I multiply the 5 times 16, I get 80, and then 80 minus 4 is 76. So the output of negative 4 is 76. Okay, now on this one, again, same thing, except now I'm dealing with a fraction. So it's 1 over 10 times negative 8. Okay, so then now we've got negative 8 times 1 over 10. Well, I just multiply the numerator. Negative 8 over 10 minus 8. Okay, so I can do this one of two ways. Now, if you guys remember how to change this into like denominators, great. If not, let's just take out the calculator. All right, so here I can put that over 1. I multiply the top and bottom by 10. That makes it like denominators. So now I have a negative 8 over 10 and negative 80 over 10. So it's negative 8 minus 80, which is negative 88 over 10. And then I want to reduce that fraction by dividing that by 2. So that would be, let's see, negative 44 over 5. And let's confirm that. Let's just make sure. So what I'm going to do is I'm going to take this and plug it into a calculator. So let's go 1 over 10 times negative 8. Then what is that? Minus 8. Okay, so it says negative 8.8. So if I click the fraction button, boom, I can see right there it's negative 44 over 5, which that's what we got here. So you guys can simply just plug this in the calculator. You can use the yellow calculator. It'll do the same thing for you. All right, so that's our final answer right there. These are the outputs we were looking for. Okay, the last one down here is, this is Pythagorean theorem. So this is all day 10. These are day 10 notes. Matter of fact, I should be writing these in. This is all review on this last one here. Okay, this section comes from day 6 and 7. And so does this up here. This is day 6 and 7. Okay, if you want to go back and look at your notes for these sections. I didn't really mention the first page, but this is going to be all day. This is day 1, basically. Day 1 and 2, really. Day 1, 2, actually 3 and 4, because this is creating the table, and then on day 3 and 4, or 4 and 5, actually, we were creating these equations. Okay, so this is 1, 2, 3, 4, and 5. Okay, that's where you can find the notes for these, and that's pretty much all of these. This, again, domain and range, you'll find that on day 6 and 7. All right, so now going back to, sorry, that's not day 10, that's actually day 9 notes. Day 10 was multiplication. Okay, so here, remember that these are our legs, the side that's right next to 90, and then this is our hypotenuse. Okay, so now, remember, it's going to be a squared plus b squared equals c squared. And our legs are the a and b, and our hypotenuse is the c. So now what I do is I just plug these in, so I get 5 squared plus 8 squared equals c squared, and I got to solve for c. So 5 squared is 25, 8 squared is 64, add those up, we get 89. Okay, and then the last step is to square root 89. Let's bring up the square root here. So square root of 89. And you see we're going to round to the nearest tenth. So 9.4. Okay, so C is 9.4. Okay, we're going to do the same thing here. Okay, except this time, one of the legs is what's missing. And we're going to call that A. Okay, so this is the other leg, and 10 is the hypotenuse. So we're going to go A squared plus 6 squared equals 10 squared. So we square the 6, we get 36. Square the 100, that's going to be 100. Then what we will want to do is subtract 36 from both sides, where we can get A by itself. Okay, so A squared equals 100 minus 36, that's 64. And then we're going to do the square root of 64 to solve for A, to get rid of that square. And that's going to be 8. So A equals 8. Okay, so that's your page 2.